If you've ever felt the irresistible urge to move along while listening to some groovy music, you're certainly in good company. Psychologists have documented a number of important links between movement and rhythm, which is an area that's of broad scientific interest to our community. As a percussionist, I'm fascinated not only by the scientific basis of rhythm, but how I can use research on rhythm perception to help with some artistic endeavors of my own. You see, in addition to directing the Maple Lab, I'm also the director for the McMaster University Percussion Ensemble. And in this context, I deal with rhythm regularly in a different artistic context. You see, in percussion ensemble, movement and rhythm have this deep, intractable link. In fact, we can't even produce our rhythmic information without using a great deal of movement. So when I'm conducting the ensemble and coaching my students in chamber music situations, I'm often discussing the importance of moving along to help keep time while performing. This is useful not only in synchronizing amongst different musicians, but also in keeping rhythmic information together. Curiously, some of the students didn't necessarily believe me when I first started talking about this. Consequently, I got involved in a series of experiments trying to better understand the complex relationship between movement, expertise, and our sense of timing and rhythm. In this paradigm, we use a woodblock pattern, which plays for several measures. In the second and third measure, we ask participants to synchronize by moving along or tapping. The fourth measure is what we call the timekeeping period, where here the participant hears silence followed by a probe tone. The probe tone comes either on time or a little bit late. So I'll give you a chance to try this yourself now. So feel free to tap along and see if you can tell if that last tone is on time or not. So what'd you think? It actually came slightly late. It's one of the hardest conditions in the experiment. And so I wanted to start off with that now. In the experiment, participants were tapping on a drum pad using a stick in what we call the movement condition. We also include a matched number of non-movement trials where we ask participants to do the task without moving. When we look at the results here, from our first several groups of psych students at McMaster without any musical training, we can look at the performance on the y-axis here in terms of their score on the task. And if we take their performance in the non-movement as a baseline, we can see that their scores go up considerably when we add in movement. And what this shows is that movement not only changes, but actually objectively improves our understanding of rhythmic information. This is an important finding, I think, scientifically, and it's also something that I talk about a lot now in my teaching and directing the ensemble, private coaching and lessons and other musical contexts. So this led to an interesting series of experiments, which I'd like to unpack now for you in this talk. So we started off using students without musical training and a drumstick, and soon became interested in what would happen if we tested percussionists in this paradigm. That led to a very surprising finding I'll go into in a moment, which caused us to wonder how this relates to the broader literature on tapping. So to try and connect here, we redid the task in a new way involving finger tapping, which led to the conclusion that actually stick tapping seems to be better across the board. To try and look at the limits of this potential conclusion, we tried to find the best musical finger tappers we could, recruited a group of expert pianists and tested them on a piano version of this task. We published this work in 3 papers. Each one was focused primarily on an issue of expertise, but when we put them together in context, I think another important issue emerges as well. So first off, in the most surprising and personally painful finding of this series of experiments, we found that without the drumstick, percussionists are actually not doing any better than the psych students without musical training. Now, to be fair, give us a drumstick and we rule the musical world, as you can see that large difference between the non-movement and movement performance when we're using a stick for percussionists. So to try and better understand how this fits with the literature, we reran this task with finger tapping and found that the expertise of percussionists with respect to movement might be specific to tapping with the drumstick. I could also relate to some affordances of the stick itself, which is what we found when we tested this on some students without musical training, because we can see there the performance was actually better for them with the stick as opposed to with the finger. So this raises some interesting questions about whether this great performance for the percussionist with a stick is because that kind of tapping is consistent with the training they've received as percussionists, And this is why we ran the group of the pianist on the piano keyboard. And we found that here, even with an equivalent amount of experience in finger tapping, they weren't getting a benefit as strong as the percussionist did from the stick tapping. So together, I think this shows an interesting story. And in some sense, it's actually a different story than we had looked at from each individual study initially, because our first goal was essentially to understand what's happening here as a function of expertise. So we published our data in 2016 on the stick tapping for the percussionists versus the non-percussionists. And then we did a percussionist, non-percussionist version of the finger tapping. And then later on, the trained pianist versus our similar control group. And so essentially, we're looking at this grid in the columns, in the vertical comparisons. But if we look across now horizontally, we can see some important other messages that come through in terms of the effectors. So I think some of the most important scientific implications of this work are looking at the effects of effectors, and that the sticks seem to help tapping and help timing perception more than the fingers. Now, that's both consistent with a growing body of research looking at these so-called effects of effectors, but also a bit different because it's showing now how this can actually have an impact on the kinds of conclusions we make about how movement affects our improvements with timing. So the other important scientific implication, which sort of makes me feel like this, is that it seems like when you take the drumstick away, even our expert percussionists are not doing any better on the non-movement task than the folks without musical training. Now, in terms of the implications here, this is a fascinating thing because we have a broad literature on how movement is related to timing, and also another literature on how musicians typically have better senses of rhythm and timing than non-musicians. Also, percussionists are frequently pointed to, and I think correctly, as having an excellent sense of rhythm in these tasks. Now, as a percussionist, I found it really awkward to try and do a rhythm task like this without moving. And so it makes me wonder if we're actually in certain tasks using musicians that move a bit in ways that we're not necessarily capturing, which could in fact then be affecting the kinds of results that we're getting. So I think there's some interesting implications about the role in which music plays, musical experience plays in the kinds of people that are doing these tasks. And that's something that I certainly keep in mind when I'm designing rhythm experiments in the future. Now, in parallel to these scientific implications, I think there's also some important implications for our artistic community. So as I said, this started in part from my experience in percussion ensemble, trying to get my students moving to the beat to try and understand and improve their performance. Now, in talking with some colleagues and other students, I find that some teachers actually advocate moving while performing, and others actually tell students that's not something they should be doing at all. Well, it's ultimately an artistic decision that's based on a number of musical considerations. I think it's important to try and message to the musical community that there are situations where moving to the beat can actually improve our understanding and our sense of time. Now, people ultimately might not want to move in certain contexts, and that's certainly something I can understand. But I think one of the important artistic implications from this work is that it can show us that movement can actually have these objective improvements in our ability to understand and process rhythm. So one of the most exciting conversations I had in the past few years was with a senior percussion colleague who told me after participating in these experiments and learning about this work, he actually changed his position around and had previously told students they shouldn't be tapping their foot while playing, and now he advocates it in certain situations. And I thought that was very exciting to see this idea, which came out of my artistic experience that led to some interesting scientific questions through these experiments, come full circle and go back into the world of the artistic implications. So before we wrap up, I just wanted to acknowledge the funding agencies and the organizations that help contribute to make this work possible. Among other things, we tested a couple of years at the Percussive Art Society International Convention with some door prizes and got some interesting insights in this data set from that. And so I appreciate all the groups that have helped. Even more importantly than the funding agencies, we've got a lot of students that have participated. The research that I presented here was all from the PhD of Fiona Manning, graduated a few years ago and has continued to keep in touch. And we've even been able to publish some papers since then. So thank you very much for your attention, and to the organizers of this conference for allowing us to have these interactions. I think it's really fascinating to talk about this information, and it's been interesting for me to have a chance to go back and look at what kinds of patterns emerge when we explore this data set broadly, because I think there's some additional information that comes from looking at all these things together that might not be clear from just doing the individual exploration of each of the papers by themselves. So thank you very much. I'd be happy to answer your questions now or send me an email later on. If you'd like any of the papers that I talked about here today, they're all available at our website, maplelab.net.